Hello, I am Sami Gabriel from Intel Labs. Since this is a very short talk, only 15 minutes, I will be doing most of the talking, but Charlie Tai is at the back here. If I get any of your very smart, hard questions, he will be able to answer them. So today I'll be talking about the membership library, which is a new library that, as of today, is online. It is part of DPDK 1711. So this work is inside Intel. It is a lot of contributors. We have Yipin, Ren, Jean, Pablo, and Antonio from Intel all contributing to this work. So the agenda for today, I will be talking about what is a membership library in 1711, what kind of usages that you should use this library in, very briefly an API overview, and also I'll give results about applying this library to accelerating OVS. Tomorrow in the OVS conference, we'll go into this into more details. So the membership library, I try to explain that with an example. So very typically, where you have clients trying to accessing backend servers, you have a list of blacklisted flows where the bad clients should get dropped. So we call this list of bad clients set. So this is a set. And the way of querying this set to know whether you are, this customer or this client is in this set or not is a membership test. So what the membership library is providing is, instead of storing the whole list in memory, consuming a lot of memory footprint, and also consuming a lot of cycles to check whether this client is in this set or not, it provides a more efficient data structure where it's very small, teeny, and the lookup should be faster. And we call the new data structure that is created a set summary. So the idea is you have a huge set, and you summarize it into a smaller data structure. So the membership library has lots of modes depending on your application and whether your application will support false positives, false negatives, the accuracy of the application. But at least the one that is in 1711 supports 4 kind of modes: a plume filter based library, vector plume filter, something called Cuckoo Disputer. I will go into details of that, and then the hash table based set summary. But again, the idea is you have a huge set of members, whether one set or multiple sets, and you get one element, and you want to know whether this element is in the set or not. The membership library will provide you with the result that this element is in the set with a very high accuracy, something like 97, 98% that this element is in the set, or it is definitely not in your set. And you can generalize the library not to include only one set, but a multiple number of sets. If you think about plume filters, this is the generalization of a plume filter. So what kind of usages you can use this library in? There are hundreds of usages that you can think of to use this library, from flow tables to web caches to databases. A lot of workloads will have huge number of keys or flows, and you want to answer the question whether this key is new or not very quickly. Some of the examples I listed here. Interested users also can go to the guide. The guide also will have, the online guide will have, the documentation that we have will have more examples about how to use the membership library and which mode to use when. One good example of using the library is distributed web cache, where you have a front end of proxies storing some objects, and clients are accessing these objects. So having a set summary in this front end of web cache, distributed web cache, will tell you whether this object is in this cache, and if it is in this cache, which one to go to, or it is in the backend server and you go into the backend server. So this speed up that you will get when you are using the set summary will, instead of storing the whole list of objects, you will get the speed up of faster lookup and less memory to store the set. Similarly, routing loops, if you want to check that there is a loop in your router, you can include the set summary in the header of the packet itself, where each router will set some bits in this header. And using the set summary library, you can check whether receiving a packet, whether your ID is in this set or not. By doing that, you will very quickly discover that there is a routing loop in the network. Security and IDS is a very common usage for this library. If you think about a web browser like Chrome, for example, you get a URL. The web browser will have to check whether this URL is safe or not. So the database that is checking against the URLs can be implemented in set summary. You get the URL. It will do a very fast query in this database. If it is a good URL, it will return back saying it is a good one. So you go ahead and send it to the backend server. But if it is a bad one, you will go ahead and send it to the more packet inspection or more IDS. Yesterday, there was a lot of talk about TCP JSO, or offloading the JSO for TCP. The set summary can also be used as a very fast way of load balancing. You get a flow key, and using set summary, you can know very quickly whether this flow is new or old one, and you can send it to the correct core, the least loaded core. Or if it is an old flow that has been inserted before, you can send it to the correct core that is doing the processing. Flow classification is another example of using the membership library, and I will have slides on the OVS that is using this technique to speed up the flow classification in OVS. Very briefly, how to use the library. It is very similar to a hash table library that is already in DPDK. You create your set summary, or create like you are creating a table in the hash library. You are just creating this set summary. You have an API to insert flows or insert keys into this created summary, and if you are inserting it, which one of the sets you are inserting it to. You have a bunch of lookup functions, whether it is a single lookup for a single element, or a bulk lookup for a set of flows or keys. And you have two flavors of the lookup function, one that will return the first match versus one that will return all the matches in all your sets. And also you have an API to delete keys. I mean, very easy API, very similar to any table, to insert, delete, and create elements and insert it in this summary. Very quickly, I will try to explain to you the POC that we did with Open vSwitch, the proof of concept that we did with Open vSwitch to speed up the flow classification in Open vSwitch. So I guess you guys are very familiar with OVS, but very quickly, the OVS has 3 layers of flow classification and exact match cache. The lower layer of classification that is doing an exact match of the flow key, and then the mega flow cache, which is doing not an exact match, but it's trying to match your key to a specific mask. And then the upper layer is doing the open flow layer. For the mega flow cache, it is composed of multiple subtables. The packet header will, if you are doing flow classification, it will go into trying to find the match in the first subtable. If you miss, you will go into the second subtable, and so on. So this it will do sequential search of subtables until you find the match. And when you find the match, you will return because the key is inserted only into one subtable. When you have a large number of subtables, the sequential search of this subtable will consume a lot of cycles. Based on our measurement, for if you have 20 subtables, which is 20 masks in your network, you will 50% of the cycles will be spent during this sequential search. So how did we use the membership library to optimize this flow classification? It's very easy. We created a summary, a set summary, and we call it the first level of indirection. A packet header or a key will come in into this data structure. Because this data structure is small and you can look it up very quickly, it will tell you with very high accuracy that this key belongs to a specific table. So instead of doing the sequential search, it will go directly to the correct table. The catch is that it will tell you the correct subtable 97% of the time or 98% of the time. So on 2-3% of the time, you have to go back and do the sequential search. But because you are doing, most of the time, you are going to one subtable directly, you get the speed up of 2 to 3x. And this result is based on 20 subtables when you have 20 of these masks. And the number of flows is 10K flows. And your traffic can hit any, uniform traffic will can hit any subtable at any time. So as part of our future work on this library, we are trying to use it into more workloads. We are trying to engage with customers to help them to optimize their workload using this library. And I mean, if any one here is having this workload of huge number of keys, and he was doing a lot of lookup on data that's consuming a lot of cycles, I mean, he can approach us to see whether this can help him or not. And also, as also part of our future work, we are trying to use this library to implement a new or an improved ACL library that has a higher update rate instead of the ACL library that we have in DPDK today that is updating at a very lower rate. I think that's it. Yeah. Some legal disclaimers and questions.
Okay, thanks very, very much, Sami, and I encourage everybody to go online and look at the documentation for that, which is very good. Yep, Sami, thanks.